Hello everyone, welcome back. So in this video we are going to cover operator overloading in more details in C++. So we are going to cover these topics. So first we will see what is operator overloading. Then we will see syntax and some examples of operator overloading. And then we will cover how to overload binary operator, unary operator, and how to do overloading using friend functions. So we'll see working examples of these all, and then at last we'll see some important points about operator overloading. So let's get started. So now, first of all, what are operators? So we use plus sign, minus sign, plus plus, increment, decrement, less than, greater than, and many more. These are all operators. So it can be arithmetic operators or logical operators. Now what are operator overloading? So operator overloading is redefining of existing functionality of operators without changing its original meaning. So what it basically means is that, let's say if you want to overload this plus operator, so we will add an extra functionality to this plus operator without changing its original functionality. So operator overloading is a compile time polymorphism. So you might be knowing what is polymorphism, right? So polymorphism is a property in C++ object oriented programming which says that same thing can be used for two different functionality at two different places. So let's take an example to understand it better. So here we have to integer a type with addition of 6 plus 5 and a string s with addition of hello plus world string. So here we see that same plus operator here is used for the addition of two integer data type, and the same plus operator here is used for the concatenation of the string, these two strings, right? So this same plus operator is being used here for two different functionality. This is what polymorphism is, and this is what operator overloading is. So basically same plus operator is being used for two different functionality. This means that the same plus operator is being overloaded with two different functionality. So here plus operator is being overloaded with two different functionality. Now let's take a look at the syntax of operator overloading. So this is how the syntax of operator overloading functions looks like. So we have return type of the functions. Then we provide the operator keyword to overload the operator. Now we provide the symbol. So this symbol is the actual operator that we want to overload. So let's say if you want to overload the plus sign, then the symbol will be the plus. Now if you want to overload the increment operator, then symbol will be plus plus. And then we provide the argument of the function, right? So this is how the syntax of operator overloading looks like, and it is always defined inside the public. So we have the return type of the function, then we provide the operator keyword, then we provide the symbol, and then arguments. Now let's take an example. So here we have a user defined data type complex, so which has real and imaginary parts. Now let's say if you want to perform the addition of these two complex numbers C1 and C2. So now when we do the addition of C1 and C2, and it is a user defined data types, so this plus operator does not know how to do or what to do with these two operands, right? So if it is, let's say if it is an integer, then plus operator knows that if it is an integer, I have to do the addition and return the result. But here it is a user defined data types, so this plus operand does not know what to do with these two operands. So let's see, take an example here. So I have defined a user class complex which has real and imaginary part, and this is the constructor to initialize the real and imaginary part whenever we initialize this class. Then this is the actual overloading function. So and here we have two complex number, complex 1 and complex 2. Now we want to do the addition of these two complex number. Now let's see what happens if there is no operator overloading functions, right? So when I commented this part, we see here that it started showing an error that no operator plus matches these operands, right? So basically this plus operator does not know what to do with these two user defined complex data types, right? So that's why it started throwing an error. and this is why we need operator overloading, so that we can redefine the property of this operator to perform an operation on user defined data structure as well, right? So let me uncomment this part now, so and run this program. Now let me see the output. So now we see here that it is returning the addition of these two complex number, right? So that's how the operator overloading helps in redefining the properties of operator for user defined data structure as well, right? So now let's take a look at the syntax. So we saw here that syntax is the return type, then operator keyword, and then symbol, and then we have the argument of the function. So here we are defining this function inside this public, right? Now we have this return type as the complex data type, then operator keyword, and then we have the symbol here plus, because we want to overload this plus operator, and then these are the arguments passed to these functions. So these functions basically do the addition of this complex number, real part is added and then imaginary part is added, and then we return the result. And that's what we are seeing here in the complex 3 as the result 5 plus iota 7, right? So we'll see and we'll understand the working of this function in more details when we take a look at the binary operator overloading. So let's see binary operator overloading. So first of all, what is binary operator? So binary operator works on two operands. So let's see here, if it is plus sign, so it always needs two operands. So here we have two operands, operand 1 and operand 2, right? So whenever we need a two operand, then that operator is called binary operators. Now we saw the example of complex number, and here we perform the operator overloading is of plus operator. So this is also an example of binary operator overloading. So let's take a look at working of how this binary overloading works in case of binary operators. So we had here defined complex 1 and complex 2. We wanted to perform the addition of these two operands, right? So the first operand calls the operator overloading function, and the second operand is passed as an argument to that function, right? So let's see here so how it works. So we have here the addition of complex 1 and complex 2. So this first operand complex 1 will call this function, this operator overloading function, and the second operand of this equation will be passed as an argument to this function. So basically this complex 1 calls this function, and then this complex 2 is passed as an argument, which is now reference to object, right? So and then this we have defined the result as a complex data type. Now we want to perform the addition and save it in the result, right? So here we have the real part. So real part is the real part of this complex 1 operand, right? Because this complex 1 is the one which has called this operator overloading function. So it has the real part. So this real part is the real part of the complex 1, and then this real part object.real is the real part of this complex 2, right? And then similarly the imaginary part is the imaginary part of complex 1, and this object.imaginary is the imaginary part of complex 2. So we perform the addition of these two and updates the result complex number, and then we return the result, right? So this result is now returned as an complex 3, stored here as an complex 3 variable. Okay? So this is how the overloading of plus operators or any binary operators works. So this first operand calls the operator overloading functions, and the second operand is passed as an argument to that function. Note here that we are passing here this complex 2 as a reference. So to make it simple, like you can do it like this as well. So this complex 2 is now being passed as an argument. So here we are passing the complex 2, so and without any reference, so this complex 2 will first be copied to this object complex and data types and object variable, and then will perform the addition. So this makes the code basically less efficient, so that's why we passed it as an reference, right? So now the whole data is not copied, only the reference is passed, so this object is pointing to the same location where this complex 2 is, and we have added here as const so that this is not this whatever argument we are passing is not should not be getting modified in between, right? So this is how we do the overloading of binary operators. So in summary, basically when we do any operation with binary operator, then the first operand calls the operator overloading function, and the second operand is passed as an argument to that operator overloading function. Now let's take a look at unary operators. So unary operators are arithmetic operators that perform an action on single operand. So here we have only one operand. In case of binary operators, we had two operands. So here now we have only one operand, so we'll perform any operation. Let's say if you want to perform negation on a num variable, then perform a minus num, right? So here we have only one operand. If you want to increment the value of num, then perform and post increment operation on that num variable. So here we have only one operator on which we have only one operand on which we perform any operations. So now let's take a look at an example. So here I have a user defined class, my class. So it has two variable x and y, and this is the constructor to initialize the value of x and y whenever we initialize any object from this class. Now this is the operator overloading function, and this is to print the value of x and y. Now what I want to do is that whenever I perform a negation on an object initiated from this class, so whenever I do the negation of that object, I should get a negative value of all the variables defined inside this class. Okay, so let's take an example. So I have my class c134. So I have an object c1 whose x value is 3 and y value is 4. Now I want to do the negation of this object. So when I do the negation of that object, I should get result as x equal to -3 and y equal to -4. Okay, so now let me comment out this operator overloading function and see. So now you see here it started to show an error that no operator minus matches this. This is because C1 is an user defined data type. So this minus operator does not know what operation I have to do on this variable, right? So that's why it is throwing an error. So this is why we need an operator overloading here to bring the intelligence that what you have to do on this user defined variable. Okay, now let's take a look at the syntax of this operator overloading function. So this is same as the one we saw for binary operators. So here we have the return type, the void return type, then we have the operator keyword, then we have the symbol as minus because we are overloading this operator, and then here we are not passing any argument. So in case of binary operators, we were passing single argument, but here we do not need to pass any argument. So this whenever we call this minus operator on any object, so it basically does is negate those number. Okay, so now let's run this program and see the output. So let's take a look at output. So now we see here that before performing this operation, value of c1 x and y was 3 and 4. Now when we perform the negation operation, we have the value as x equal to -3 and y equal to -4. So this is how we do the unary operator overloading. So we overloaded here the minus operator to perform negation on all the variables that any object from this my class has. Okay. Now let's take a look at overloading binary operators using friend functions. So operator overloading function must be preceded by the friend keyword and declare the function in the class scope. So in case if you are using a friend function and overloading any binary operators or any operators using friend function, then we must define it by a friend keyword and we must declare that in the class scope. So let's take a look here. So we are defining this is our operator overloading function, which is same as that complex binary operator overloading. So we are overloading here plus operator. So now if we are using it as a friend function, then we must declare it by a friend keyword and it must be inside the class scope. So this is the class scope, so it is inside that class. So we declare that operator overloading function inside the class scope. Okay. Now take a look at the next point. So all the working and implementation would be same as the binary operator function, except this function will be implemented outside the class. So everything whatever we saw till now, the working of operator overloading is same, and even the implementation is same. The only difference is that this function whatever we declared inside the class scope is defined or is implemented outside the class scope. So class scope ended here. This is the class. So it ended here. So we defined it outside. We implemented that friend function outside that class. So here, if we look at the syntax, it is same. So we have the return type of the function, then operator keyword, then the symbol plus. We are overloading this plus operator, and then we pass the argument. So now take a look here that we are passing two argument here. The first argument is object1 and second object2. So complex 1 will be object1 and complex 2 will be the object2. So here we are passing two argument, but if you remember, in case of binary operators, we were passing only single argument. This is because the first operand where itself we are calling this function, and we needed only the second operand to pass as an argument. But in case of friend function, we need to pass these two operands as an argument. So this complex 1 will be reference to object 1 and complex 2 will be reference to object 2, and then this complex number addition will happen and this will return the result. Okay. So let's run this program and see the output. Friend.cpp, set output. So now you see that it is returning the addition of these two complex number. So this is how we use the friend function. Now let's take a look at some important points about operator overloading. The first point is that the operator functions must be either a non-static member function or a friend function. Okay. The second point is that if in the case of non-static member function, the binary operator should have only one argument and the unary should not have any argument. So we saw that in case of if it is not a friend function, so basically it's in non-static member function, we are passing only one argument, right? In case of binary operator, and in case of unary operator, there is no argument, right? In case of a friend function, the binary operator should have only two argument and unary should have only one argument. So if we are using the friend function, then the binary operator will have the two arguments. So that we saw here that in friend function, we passes two arguments here, the operand 1 and operand 2 for binary operators. Similarly, for unary operators, we need to pass one argument. Now all the class members functions should be public if operator overloading is implemented. So we saw that we were always defining it inside the public, right? So we operator overloading function is always defined inside the public. Now there are four operators that cannot be overloaded. So these are the four operators that cannot be overloaded in C++. The first one is the scope resolution, second one is the member selection dot operator, third one is member selection through pointer to function, and fourth one is ternary operator. So these are the operators that cannot be overloaded. So this is all about operator overloading. Thank you.